Okay, good morning, and we'll start the class. Let others join as usual. So, last class we were discussing link state routing. That was based on Dijkstra algorithm. Before that, we had seen distance vector routing and routing information protocol is a distance vector routing algorithm. So we need to see the link state routing algorithm open shortest path first. So we'll see OSPF. So what we had seen in link state routing is each node has the entire topology. Okay, each node has entire topology. So you can see in this figure that each node has the entire topology. And the 4 steps in link state routing is each node will create link state packet. That is the first step. Each node will create link state packet. And then it will be disseminated by flooding. It is not just to the immediate neighbors. It is throughout the network. Flooding is router will receive link state packet through one interface and send it out through other interfaces. We had seen that there are a number and age for these link state packets. Then each node will obtain the link state packets. It will update and form shortest path tree using Dijkstra algorithm. And then the node can calculate the least cost route and create the routing table. So those are the 4 steps which can be done using the Dijkstra algorithm. The flowchart is we had seen. Hello? 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 ആരാ ആരാ ഞാൻ ക്ലാസ്സിലാണ് സാറേ, പിന്നെ വിളിക്കാം. ക്ലാസ് ആ ആ ശരി. So the link state routing uses Dijkstra algorithm. A root node is there. There are 2 lists, tentative list and permanent list. Initially all nodes are in the tentative list. Based on the least cost, it will be moved to the permanent list. So among node in tentative list, move the one with shortest path to permanent list. Continue doing this until this tentative list is empty. We had seen that. So this figure we had seen. For A, this is the root. The node A is to the permanent list. Then move C to the permanent list, which is the least cost, and continue doing so. And finally, the shortest path tree can be calculated, and from which we can create a table, the least cost, to different nodes. To itself is 0, to other nodes, and through the next hop router. In case of E, it has to go through C. So these are the 4 steps. And the flowchart can be written as an algorithm. Here, there is a set. Least cost is definitely known. So you are updating the algorithm until everything moves into n dash. So until all the set of nodes are moved to this list, we will continue the algorithm. So that is written mathematically in the form of a algorithm which has to be executed in the nodes. It has to be executed. So we need algorithms, mathematical algorithms. And we had seen these steps for a node U, how we get the least cost. W is moved first, which had minimum cost. Then X is moved, which had the next minimum cost, and the shortest path is circled, and you can form the routing table. So the cost, what do you mean by cost here? So when you think as a traffic, you are moving some distance on one road, you are moving another distance on another road, we naturally take the shortest distance. But the cost in networking terminology, some links may be 56 kbps, some link may be 1 mbps, some may be 10 mbps. So the bandwidth, etc., has to be taken into consideration. So the cost doesn't mean the distance in link state routing. So initially, when internet was devised, it was called the ARPANET, the Advanced Research Project Agency, US Defense. So that net was ARPANET, and it was later converted to internet. So there they used a distance vector first. Then they moved to link state. So the cost means initially in olden times, every links were 56 kbps, or there was not much variation. But when you think in terms of networking nowadays, the cost should be considering the bandwidth, the pipe, how much of flow it occurs in the pipe. So somehow we assume that cost is known for every link. Maybe one node can send a packet, and a packet will return, and it can find the cost. So that is the assumption. So these are the edges in a graph. These are the nodes in a graph. Mathematically, this is a graph, and this is the cost of each edge. So if I just put a slide to compare link state and distance vector. This is taken from that Kurosuro's book. So you can just go through it. What is the comparison? Here in link state, what you have is flooding. You send to everyone else. Whereas in distance vector, it is exchanged between neighbors only. So the algorithm cost would be different, complexity would be different, the convergence time will vary. Okay. So those are the comparisons between link state and distance vector. Now, OSPF, Open Shortest Path First, is a routing protocol which is based on link state routing. So this OSPF divides autonomous systems into areas. So we had seen that intra-domain routing is there, that is within the autonomous system. So both RIP and OSPF, both are intra-domain within the autonomous system. This autonomous system itself is divided into areas. So area is small networks within. So area is a collection of host routers networks within an autonomous system. All network inside an area must be connected. So router inside an area flood the area with routing info. Now at the border of an area, special routers called border area routers summarize the information about the area and send it to other areas. Among the areas inside an autonomous system, a special area called backbone. All the areas inside an autonomous system must be connected to backbone. In other words, backbone serves as primary area and other areas as secondary area. So this is the concept of areas within an autonomous system. So this whole thing is an autonomous system that itself is divided into area 1, area 2, area 0. This is called the backbone. All other areas should be connected to this. Now this would go to other autonomous system. So for an area, there would be an area border router for every area. So OSPF divides the autonomous systems into area with a router at the border and a backbone, which is the area 0. And all areas should be connected to the backbone. That is what is written here. Now OSPF routing. So if because of some problem connectivity between a backbone and an area is broken, virtual link between routers must be created by admin to allow continuity of function of the backbone as primary area. In case some link is broken with an area, some virtual link has to be created by the administrator. Now metric. Metric means assign a cost to each route. So we just write a number on the edge. So based on the type of service, this could be the delay. So we have to minimize delay or maximize throughput. So router can have multiple routing table based on different metric. So sometimes some service require minimum delay, some service maximize throughput. So router can have multiple routing table based on different metrics. Now 4 types of link we will just see. So link means, so if link between routers broken, admin has to create a virtual link. So there is a virtual link type. Then there's a point-to-point type link, transient link, and stub link. We'll just see what it is. Point-to-point is between 2 points, without any router in between. This is bidirectional and metric shown at the 2 ends, one for each direction. Here both are same. Each direction need not have the same metric. Point transient link is a network with many routers. Data can enter through any router and leave through any router. So this is a transient network. So let's consider this K. Now everything is a neighbor if you look at this. So A is connected to everyone else. So to represent this, we can have this sort of representation to show that everyone is through, which is actually not, this network is represented here. So designated router, which is actually physically, but one of the router takes the responsibility and acts as a true router and as a designated router and has a one neighbor. So this is a neighborhood representation. So such a type of link is called transit. This is just a representation. This is also another representation. So better representation is this one. However, we don't have a node here or a router here, which is a designated router, which one of these nodes will act as a designated router as well as an actual router. Sublink. So it is connected to router called a sublink. It can communicate with this. one link is there here. So here we have an autonomous system, 7 networks and 6 routers. In OSPF, we would sometimes represent like this. This may be designated router, and these 3 are the actual ABC. So one of these would take its role here, and this also as a designated router and other routers. So this could be one representation in an OSPF rather than this one. This one is the actual thing. So OSPF routing is based on, so whatever we had earlier class as a link state, everything is this basic functions takes place in OSPF. It's a link state routing, not a distance vector routing. Now, we have seen this link state routing and distance vector routing. Now, we need to know about one more routing, which is inter-AS between the autonomous systems. So, distance vector and link states were intra-domain within the autonomous system. So it cannot be used, those mechanism cannot be used for inter-domain or inter-AS. So we have third type of routing, which is called path vector routing. This is used for inter-autonomous system routing, or the example which we see is BGP or border gateway routing. So that is based on path vector. So here, the concept is, within an autonomous system, there is a representative node which will act on behalf of the autonomous system called speaker node. So speaker node in an autonomous system create a routing table and advertises it to speaker node in neighboring autonomous system. So speaker node advertises the path. So this is based on path and not metric. So the border gateway protocol, or the BGP, is an inter-autonomous system routing protocol, which is based on path. It is not based on metric. And it is a protocol to connect different autonomous systems. Whereas RIP and OSPF are within the autonomous system. So we have different autonomous system, and each autonomous system has a speaker node which will act on behalf of this autonomous system. So these are the speaker nodes. So A1, B1, C1, D1 are speaker nodes of AS1, AS2, AS3, AS4, 4 autonomous systems. And we don't use OSPF or RIP for inter-autonomous system routing. We use path vector routing. We need the path. So within this autonomous system, this speaker node has a path. This speaker node will have a path in this AS2, and every speaker node will have a table. So path vector routing, initialization and sharing. So in every mechanism, you have initial information, then you pass it on to others, and everyone else will update. So this mechanism goes on. So in this beginning, each speaker node can know reachability inside its AS. Now sharing, as in other routing protocol, path vector also, speaker node in an AS shares its table with immediate neighbors. So node A1 will share its table with speaker node B1 and C1, and C1 will share with D1, B1, A1. So amongst the speaker node, they will share their table, and they will create a path. So updating. When a speaker node receives a 2-column table from neighbor, it updates its own table by adding the nodes that are not in its routing table and adding its own autonomous system and the autonomous system that are sent in the table. After a while, each speaker node has a table and knows how to reach nodes in other autonomous systems. So speaker node gets the information from neighboring speaker nodes, then it can update its routing table. And finally, so A1 is a speaker node. So how to reach A1 to A5 within autonomous system 1? How to reach B1 to B4 within autonomous system 2? How to reach C1 to C3 nodes within autonomous system 3? And how to reach D1 to D4 within autonomous system 4? That path will be known after all the speaker nodes communicate to each other and each speaker node updates its routing table. So tables for each speaker node after system is stabilized. If router A1 receives packet for node A3, then it knows that path is in AS1. You can just look at this table. But if a speaker node A1 receives packet for D1, so speaker node A1 gets a packet for D1, then it should know that path is to this place. So this table would have been updated. The table. Now it will know that it has to go from AS1 to AS2. I think AS3 is also there. AS1 to AS2, AS3, and AS4. So that path, it depends on the value in that. So this is AS1, AS2, AS3, AS4. So like that, should go to AS1 to AS2 and then to AS3. But here it is not there. So it is some mistake in that table and figure in the book. Should go from AS1, AS2. Anyway, AS3 should be there to go to AS4. So this is how the routing tables in the speaker nodes would be after sharing and updation of information. The path would be there. This is called path vector routing. The border gateway protocol is an inter-domain routing protocol using path vector routing. So we divide autonomous system into three: stub, multi-homed, and transit, as in the case of links. Stub autonomous system has only one connection to another autonomous system. The inter-domain data traffic in a stub autonomous system can either be created or terminated in the autonomous system. Stub means only one connection. Data traffic hence cannot pass through the stub. So it's either a source or a sink. Multi-home have more than one connection, but it also would be source or a sink. It can receive data from more than one autonomous system, send to more than one autonomous system, but there is no transient traffic, means through that you cannot go to somewhere else. It does not allow data coming from one autonomous system and going to another autonomous system to pass through. This is also in a way a source or a sink. So the data cannot pass through this multi-home autonomous system. Now transit autonomous system means data can pass through. A transit autonomous system, multi-homed autonomous, that also allows transient traffic, means data can pass through that. So actually the path, I mentioned only path, but it is a collection of attributes. Path is a collection of attributes. So each attribute would give some information about the path. So the attribute itself is well-known and optional attribute. So two types. Something which everyone should know, must recognize, is well-known attribute. An optional attribute is that need not be recognized by every router. So actually the path is a list of attributes. So well-known attributes itself is, which is recognized by all routers, are mandatory and discretionary. So mandatory attribute is one that must appear in the description of a node. Discretionary attribute is one that must be recognized by each router, but not required to be included in every update. So like a mandatory attribute example is origin, defines source of a routing info like RIP, OSPF, so on. Path, origin path defines the list of autonomous system through which the destination can be reached. Next hop defines the next hop router to which the data packet should be send. So all these three attributes would be there in mandatory attribute. These three are certain types of attributes which are mandatory. So origin, source, the path, the next hop. So this we have seen in some way in previous classes. So these are forming an attribute in the path. Now optional attribute, two types, transitive and non-transitive. Transitive attribute is one that must be passed to the next router by the router that has not implemented this attribute. Non-transitive attribute is one that must be discarded if the receiving router has not implemented it. So this should be passed. Such type of attributes are called transitive attribute and non-transitive attribute. So these are the mechanism by which this border gateway protocol work. So these are all very extensive subjects, say if you attempt to study. So we are just getting the rudimentary mechanisms of this inter-domain routing. BGP session. Session is a connection established between two BGP routers only for the sake of exchanging routing information. For reliability, BGP session uses TCP connection. Session comes in transport layer, and we haven't seen this TCP connection. So that is used in BGP sessions. Difference between connection in TCP made for BGP and other application. When a TCP connection is created for BGP, it can last for a long time until something unusual happens. For this reason, BGP sessions are sometimes referred to as semi-permanent connection. More or less permanent, it lasts a long duration. Similar to TCP connection, TCP it is in the transport layer, it is called a session. So BGP also have session which are more or less long duration, it is called semi-permanent. So these are the mechanisms used in BGP. So internal and external BGP session. So within this BGP session is this dotted internal and external BGP session used to exchange information between two speaker nodes. So external BGP session is this one. Session is terminology used in transport layer. So same thing used here. So used to exchange information between two speaker nodes belonging to two different AS. Internal BGP session, on the other hand, is used to exchange routing information between two routers inside an AS. So what we had seen basically is routing protocols. The whole internet is divided into an autonomous system. So within an autonomous system, we have either distance vector routing, which is RIP, or link state routing, which is OSPF. And amongst the autonomous system, we have path vector routing, which is the border gateway protocol. So path vector routing is actually, path means it is a list of attribute. So there are various types of attribute, various types of links, and sessions are there for exchange of these attributes and this path. And the network itself, like links, can be transit autonomous system in which it passes through that autonomous system, or multi-homed or stub in which they are only source or destination. So ultimately paths, the path would be there in the tables. And these tables, these mechanism will be exchange of available paths in initial case with each speaker nodes. It would be exchange and it would be build up. So that is the path vector routing. So it depends on the speaker nodes, and it uses border gateway uses protocol uses this path vector.